engineering variables involving length and time. There are quite a few of these, right? There are quite a few of things that have length and time together, right? So one of the first things we're going to talk about is speed. Speed is kind of the same as velocity, right? Anybody tell me the difference between speed and velocity?
Velocity has a direction.
Correct. So velocity has direction, all right, whereas speed does not. Okay, speed is more of a magnitude. So it's the magnitude of the velocity is speed. Okay. So direction is a vector quantity. So this is a vector because it has a direction. This one does not have a vector, so it's a scalar quantity. All right. Vector and scalar, if you've taken physics or honors pre-calc, you have a little bit of idea what they are, right? If you don't, not to worry about it, okay? So vector and a scalar, that's speed and velocity. So that's good. So how do we calculate speed? How do we calculate speed? Speed is very easily calculated, right? Speed is nothing more than the distance traveled, right? Or displacement over the amount of time, right? So this is just speed or velocity, right? Okay, so it's a distance traveled divided by time, right? So if you traveled 120 miles in 2 hours, right? Your speed is going to be 60 miles per hour. Simple as that, right? Okay, so let's see. On table 8.2, there is a situation and some example of some speeds, right? So average speed of a person walking is about 1 point, whatever. So it's basically what? It's about 3 miles per hour, right? 3 miles per hour, you can walk 3 miles per hour, right? The fastest runner in the world runs at about 23 miles per hour. Okay. Professional tennis player serving a ball is about 130 miles per hour. Okay. And so there are things that are on and on. These are kind of things that are nice to know, like the average speed of a plane is about 555. I usually go with about 500, right? It's about 500 miles per hour. Okay. Right. So if you are going to travel from here to LA, right? LA is about what? 1,000 miles. It's about how many miles is it? Does anybody know how many miles it is from here to LA? LA is about a 2.5 hours plane ride, right? Okay. So these are the type of things that you can calculate in your head, right? Have some sort of an idea, right? Okay. All right, so that's that. So let's flip the page and we have linear acceleration. Acceleration is how quickly is the speed changing, right? So we had the speed being delta x over delta t, whereas the acceleration is going to be the change in speed or velocity over time. Okay, you can notice that I'm kind of using speed and velocity synonymously here, which is a big no-no if you're doing physics and engineering. It's basically given that you know where the direction is, so you can kind of use them as being the same. All right. So acceleration is the difference in the velocity or the change in velocity over time. In other words, how quickly are you changing velocity, right? So if you are, let's say that you started out at time one, or so when you were, well, we'll call it time 1 second, right? You were going 120 miles per hour, and then within 100 seconds, or after 101 seconds, right? Or let's just say 2 hours. This is 1 hour and 2 hours, right? And then I'm going 60 miles per hour. Okay. So then the acceleration is going to be what? 60 minus 120, right? Because this is where you end up at. This is where you started. So it's 60 minus 120, 2 minus 1. So it's going to be minus 60 over 2. So it's a minus 30, right? So this is basically miles per hour squared, right? Okay. So what is this? So you are what? What's happening here? You have a negative acceleration, which means that you are decelerating. You're slowing down, right? Okay. All right. So that's the acceleration. Okay. Now let's talk about gravity. We can talk about gravity. Okay. When we talk about gravity, we know the gravitational constant, right? So acceleration is a change in speed, right? So the gravitational constant is something like that. So the gravitational constant G is going to be equal to 9.81 meters per second squared, or 32 feet per second squared, right? Okay, so this is the gravitational constant, right? So if you drop something, the Earth is going to pull that object down, right? And it's going to pull it down at this type of acceleration. This is the type of acceleration that will be applied to an object in free fall, right? Okay, like that. Okay, so this is G. Okay, so okay. All right, so it's going to give us, now it's going to talk about, we're going to talk about gravitational force. Gravitational force is, you've seen this before, okay? You've seen this before. If you have an object that has a mass of m1, an object having a mass of m2, this is m1, this is m2, the distance of r, the force that's grabbing each other, right, that's attracting each other is going to be this. Now, one common mistake that you guys make here is that you say, oh, G, yeah, G is this, okay? Well, this G is not this, and that's why it's written in a capital G. Okay, this G is different. This is the universal gravitational attraction, okay, and it is 6.7 times 10 to the negative 11th. Okay, 6.7 times 10 to the negative 11th. Meters cubed, kilograms, second squared. So meters cubed, kilograms, second squared. Okay, all right. So this G here is totally different than this G here. Okay, always remember that. Okay. So let's go to page 251. And in page 251, we are going to do, or try to replicate the famous Newton's experiment where he drops stuff from the Tower in Pisa, right? He's going to drop stuff, and if you look at table 8.3, there is the time. So as time goes by, we are checking the velocity and the distance traveled, right? So the velocity and distance traveled. If you look at the speed of the falling object, as time goes by, you can see that it's being added 9.81 all the time, right? And that is because of the G is 9.81, right? So G is equal to 9.81 meters per second squared, right? So basically, if you wanted to calculate it, the velocity would be equal to GT, okay? Later on, you will learn that the velocity of an object is going to be equal to the initial velocity plus AT, the acceleration, times the time here, right? So in this case, our initial velocity was 0 because it's a free fall object. There is no initial velocity. And A is the acceleration, which is G, right? So this is often, you will see it as minus GT because, again, G is going downward, and that's why it's a negative here, okay? Okay. Distance traveled, okay, distance traveled, the same thing. Distance traveled is sometimes usually called S. Okay, S is also going to be 1/2 AT squared plus V naught T plus S naught, where again, V naught is the initial velocity. Initial velocity here is 0, and this is going to be the initial height. So I then call, if I call a point where I'm dropping, where I'm initially dropping it from, if I call this point 0, okay, then the distance traveled is going to be negative 1/2 GT squared. Again, why is it negative? Because we're traveling from here to a lower position, okay? And as you can see, the D there is 1/2 GT squared, which is the same thing here, right? Okay. Okay, so that's that. Let's look at example number 8.3. Example number 8.3. So let's look at example number 8.3 here. And 8.3, it gives you a graph of the change in velocity of a car. It's a car. Okay, so this is the velocity. This is time in seconds, time in seconds, and kilometer per hour. So here is kilometer per hour, and we have time in seconds here, right? So what happens here? So we're going here, and the times are what, 15? And then in 15 seconds, and then for the next 30 minutes, the car moves at a constant speed of 100. So for 30 minutes, so it's 30 minutes in seconds is going to be what? 1800, right? So from here to here is 1800. So here, this point is going to be 1815. And then it's gonna go to 0 at 1825. So what happened here? So the car is at a standstill, right? The velocity is 0. Then it accelerates for the first 15 seconds, accelerates up to 100 kilometers per hour. What is 100 kilometers per hour in miles per hour? Can anybody tell me? Approximately? Does anybody know? This is about 60 miles an hour, right? Approximately 60 miles per hour, okay? Over here, okay? Anyway, so it's gonna accelerate to 100 kilometers per hour, stays constant for 30 minutes, and then after the 30-minute point, it decelerates, right? Or it's gonna slow down, and then the velocity is 0 at 1825, okay? So the question is, what is the distance traveled? Distance traveled is what? So velocity is what? Distance traveled divided by time. Okay, so I'm trying to find what D is. So D is going to be equal to VT right here, right? Basically, it's going to be velocity times time. Well, so what is it? It is the area underneath this curve. So the area underneath this curve is the distance traveled. So if I asked you how far it traveled the first 15 seconds, okay, so what I'm asking you is the 15 seconds, I'm asking you the area underneath here. Okay, so I have to be able to calculate this area. Okay, normally you would do an integral. We don't know how to do integrals yet. But luckily, this is just a triangle. So all we're doing is finding the area of the triangle here. So the area of the triangle is what? I have 100 kilometers per hour. So this height is 100 kilometers per hour. Right. The base is 15 seconds. Then I have to divide this by 1/2, right? Because it's a triangle. Because it's 1/2 of the base times the height, right? 1/2 base times the height. Okay, the problem is I have to now change, hours and seconds, right? So I have 1 hour is this many seconds. So now the hours cancel out, the seconds cancel out, and this is what I'm gonna get. So I'm gonna get what? 15 times that is 1500. So I have 1500 over here. I have 1/2, and I have this, so it's gonna be 7200. It's gonna be kilometers, right? That's all I have left is kilometers. So that'll be your answer. Okay.
Mr. On,
Yes.
the units for our velocity, will they always be kilometers per hour?
No, just in this example, it is kilometers per hour. Okay.
Yeah.
And the reason why I kind of emphasize this, I just want you to get a feel for what the difference between the miles and kilometer is, right? Because what is 1 mile is what? 1.6 kilometers, right? So if you times this by 1.6, you're going to get 96, close to 100. Okay? All right? So, okay, what if I asked you, so this is also, you can go ahead and change this, right? So instead of saying this kilometers per hour, kilometers, you can say that in meters, since 1 kilometer is 1,000 meters, you can go do this, right? Right? Because I can ask the question in any way I want to. Okay. If I ask you what was the distance traveled here, okay, that'd be what? This is nothing more than 1,800 kilometers per hour times. This was 30 minutes, so it's going to be 1/2 hour, right? 1/2 hour. Hours cancel out, and I would immediately get 900 kilometers. Okay, so the distance traveled in this from between 15 seconds and here would be 900 kilometers per hour, 900 kilometers, right? And then I can go ahead and add this guy too, and I can add them all together, and I can find out what the area or distance traveled is, right? You get the point here, right? So you're calculating the area underneath the curve, right? Okay. All right, we're gonna stop here.